The farthest human-made object, Voyager 1, is in trouble. But what is the issue? Well, the spacecraft, which has been traveling for nearly half a century now, is experiencing serious issues, sending data back to Earth. It has suddenly started sending a strange pattern of ones and zeros, which doesn't make any sense. This has made engineers and scientists anxious to diagnose and fix the problem from 24 billion kilometers away, so that the historic mission can continue providing invaluable insights from its journey through space. But what exactly is causing the spacecraft to transmit this corrupted data? The spacecraft's behavior is uncertain. Is it a small anomaly or a critical malfunction? Considering its age and distance, are there any feasible repair options? To answer all these questions, it is important to understand why the probe is transmitting a strange pattern of binary digits. You see, like earthly computers, Voyager communicates through binary code, using just zeros and ones. These bits combine to form instructions, data, even images and sounds. Deciphering this strange pattern transmitted by Voyager holds the key to answering your questions about its behavior. There are three main computers on board in Voyager 1, and the problem is linked to two of them. The first computer is called the Flight Data System, or the FDS. The Flight Data System, or the FDS, plays a crucial role tasked with gathering two distinct data streams: scientific observations from onboard instruments and held telemetry, indicating the spacecraft's well-being. This information is meticulously collected in binary format before being processed and combined by the FDS into a single data package for transmission. This package is then sent to the second computer, the Computer Command System, containing the Telemetry Modulation Unit, or the TMU. The TMU acts as the data translator, converting its binary format into a carrier signal suitable for transmission to Earth. These radio waves, now carrying the spacecraft's message, embark on their journey under the guidance of the TMU. Their destination is the Deep Space Network, or the DSN. This global network of colossal radio antennas, strategically positioned in California, Spain, and Australia, acts as Earth's outstretched ear, ensuring uninterrupted communication with various spacecrafts as our planet rotates. Once the binary data is received, it's further processed in data centers. Finally, the binary data is converted into human-readable formats like numerical values, graphs, or images that are further used for analysis and research. For over 4 decades, Voyager 1 has been sharing information in this manner, but recently the spacecraft's communication system has witnessed a mysterious problem. Instead of sending the usual mix of scientific information and spacecraft-held data, the TMU has been reported to emit a strange and repetitive sequence of ones and zeros that doesn't seem to make any sense. NASA hasn't released the exact pattern that the Voyager probe is sending. As a preliminary report on the issue, NASA has concluded that the primary problem lies with the FDS. It is causing the TMU to transmit irrational binary messages back to Earth. Usually, when such a problem arises, the first solution is to restart the FDS by turning it off and back on again. This approach often fixes most technological problems here on Earth and even in space. For example, back in 2010, when Voyager 2's data showed a similar issue due to a flip in one of the bits. The team performed a resetting command for the memory of the FDS, which successfully resolved the issue. This on-off mechanism even solved a glitch faced by the Hubble Space Telescope a couple of years ago. Following the same strategy, a reset was also performed in the FDS this time, but that didn't help. The problem persisted when the system was turned back on. This has prompted engineers and scientists to come up with some robust solutions. But doing this is more challenging than it seems to be. First of all, the spacecraft was built almost half a century ago, which means that was built by people who have long since retired. So the present team needs to go very deep into the old documents to see how the probe and its computers work. The technology is highly outdated, although several software updates have been carried out in recent decades. As a comparison, today, even the cell phone in your hand can handle more than 100 billion instructions a second, but Voyager's computers can process just 8,000 a second. Secondly, at the current distance of Voyager 1, it takes almost 22.5 hours for light to travel one way to Earth. So whenever the team comes up with a possible solution and tries something, it's a 45-hour round-trip wait for the signals to get there and response to return. But on the positive side, this isn't the first time Voyager 1 has sent back random data. Even in 2022, the probe returned some of its data through a broken computer on board, corrupting the outgoing messages. However, the engineers at NASA figured out the problem and fixed it. Voyager 1 wasn't supposed to fly this long. This amazing mission started by exploring a solar system's outer planets, but it has found so much cool stuff beyond that. It uses a special battery that slowly runs out of juice. Because of this, the scientists have to pick and choose which parts of the spacecraft to keep running to make the battery last longer. The last picture of a home planet taken by Voyager 1 was in 14 Feb in 1990. It snapped a series of photos called a family portrait of a solar system. One especially famous image, the pale blue dot, shows Earth as a speck, just a dot of light from a whopping 3.7 billion miles or 6 billion kilometers away. Pretty amazing, right? It reminds us how small we are in the grand scheme of things, but also how special this little blue planet is. Our space explorer, Voyager 1, took some incredible pics like the pale blue dot, but then it was time to power down. Cameras and other gadgets were sent to sleep to save energy. As of February 2024, only 4 out of 10 instruments are still sending messages from way out there. The data sent by Voyager 1 is critical because the probe is now in a part of space where the sun's influence is feeble and is telling us about things like cosmic rays and magnetic fields in a place we've never been able to study directly before. However, as Voyager 1 travels further away, staying in touch gets more challenging. Signals take longer to travel and they're much weaker by the time they reach us. Despite these challenges, Voyager 1's journey continues. It's not headed towards any particular star or planet, but in about 40,000 years, it will pass relatively close to a star named Gliese 445. In human terms, this might be a long time, but it's a blink of an eye on the cosmic scale. One of the most special things about Voyager 1 is the golden record it keeps. The record is like a time capsule filled with sounds and images from Earth, intended to show other life forms, if they ever find it, what life is like on our planet. This record also has instructions on how to play it and a map showing where it came from. The idea was to share a bit of our world with whoever might find it, even if that happens millions of years from now. It's like a bottle thrown in the cosmic ocean, carrying a message of who we are from a little blue planet far away. So, Voyager 1's journey isn't just a scientific mission, it's a story of human curiosity and ambition. Looking at what the twins have achieved so far, there is still hope for the recent technical glitch to be fixed. If this issue is resolved, scientists are hopeful that the spacecraft may continue until its 50th birthday. Thanks for watching and subscribe for even more videos like this.